Should I just like scroll through it and go through as we go, or should I take questions? Alright, here, I'll go through and do like a quick explanation for each one, and then if you want a more detailed explanation for that one, stop me and tell me like, dig deeper. Alright. It is recorded, so if you miss something, you can go back. So, the first one we did in class, right? Alright, second one, we got a mean of 100, standard deviation of 10. So if I just think about drawing that out, what this means is what's the probability that x is greater than 15. So probability and area and percent are all the same idea. So what probability x is greater than 115. So 115 is here. And greater than that would be this shaded region. Well, they're saying which of these is equivalent. So A says the probability x is less than 115. Well, that's way bigger than this, right? So that doesn't match. X is less than or equal to, still way bigger than this. That doesn't match. X is less than 85. Is that the same? There we go. 85 to 115 would be like this chunk in the middle here. And then 1 minus. So what does 1 minus tell you to do? Like flip it around, right? So 1 minus x is less than 85 would be actually this chunk here. Oh yeah, we're doing something for some amount of time. Yeah.
Just a couple minutes.
Oh yeah, go for it. Yeah.
Okay.
Go.
All right. Hello everyone. So I know that we normally do this after winter break, but we're going to talk about AP test registration. So I'm going to pass these forms around. If you've already seen me today, you don't need a second copy. You can see the ones you had from earlier today. So we are bumping up AP test registration for a couple of reasons. The first reason is that next year, AP is moving it up for everyone. So everyone in the country will register in October. So we're kind of doing a practice round here, taking stair steps. The other reason is that I will be out on maternity leave in January and February when we normally do it. So we want to make sure that we get all the information correct before then. So that way we know. So that we don't miss anything and not getting the right number of tests for everybody. Cool. All right. Thank you. All right. Is anyone back here need? Yeah. So the way that we register for this is the same as last year. What you will do is you will mark down the test that you are signing up for. So make sure you're signing up for the right test. If you're in English language, make sure you check that. Don't check English literature, that sort of thing. And we need this form and your first part of your payment back by November 21st. So that's the Wednesday before Thanksgiving. The nice thing about bumping it up is that we have more time for payment plans. So if it is easier to pay in a lump sum each month, then we can definitely do that. You don't have to pay everything up front by November 21st. The other thing is that if you sign up now and decide, in January that you don't want to take the test, you have until February 15th to get a full refund. So you can, even though I'll be out, you can email me and I'll make sure that money gets back to you if you decide that you don't want to take the test. After February 15th, then we can only give you a partial refund. Alright, so if you qualify for free or reduced lunch, there is a reduced price. So please don't let money be an issue. Please just let me know that you qualify. And that way we'll make sure that you get that reduced price for the AP test. And if you qualify, if you have an IEP and need accommodations, please let Mr. Giller know before winter break. So that way we can make sure that we request those in time to get you your accommodations. I think does anyone have any questions about AP testing? Cool. Thank you.
Well, thank you.
Alright. So day before Thanksgiving, if you could just get back to me, and you can turn it into the front office to Ms. Pinnis or Ms. Disney as well. Alright, thank you.
That's it. Okay. This one here, they have the largest standard deviation. So standard deviation is the average distance from the mean. So what you bunch of points clustered in the middle toward the mean, this one will be the smallest. Because your mean is like around there, and the majority of your points are also around there. This would be like, if you think about this, we talked about someone that's moody. Like, this is like their normal mood, and they're not in a bad mood very often, they're not in a really great mood very often, they're just kind of steady Eddie. This would be the largest, where this is their average mood, but they're like hardly ever in that. They're always like either super grouchy or super happy. I don't know. I'm kind of losing the metaphor here, but this is the largest standard deviation because there's more points farther away from the mean than there are close to the mean. Is that okay? This one we did in class, right? All right. Percentile rank. So percentile rank means percent below. Percent at or below, technically. 85 miles. So what I did was just put a line where the 85 is. And I'm going to calculate the percentage of dots that are below that. So I counted those dots. There's 20 dots that are down here. There's 28 dots total. So I want to know the percent that's below. I'm just going to figure out, like, just count the actual percentage. 20 on 28 is like 71% or so. So that's B. How's that, fella? Yeah.
Can you do like the boxes and whisker plot thing instead? Because that's how I did it. Like I found the mean, and then I found like the 75%. Yeah, I found the median, and then I found the 75%.
So where was the 75%? Like 80, was it like 88?
82-ish or 85-ish. Yeah.
Oh, okay.
Dot right
And then so you just drop down to
so it's like it's a little less than 70.
That's kind of guesstimating because the only numbers that tells you is 50% and 75%. If I didn't have the data, I could kind of wiggle my way around, but I think this is more accurate because we can actually count them. All right, this one here. The distribution of test scores is not symmetric. What's the best estimate? Well, if it's not symmetric, we can't really do anything. So if you think about like inverse normal, you need the distribution to be normal. Normal CDF, you need the distribution to be normal. We can't use those if it's not normal. So as soon as it says not symmetric, and the z-score is standard deviations above the mean in a normal distribution. So if it's not normal, like none of that stuff even applies. If it were normal, I'm not saying that it is, but like if it were, what would you do? If the third quartile, I have a percentage. What percentage is the third quartile? 75. If I have a percentage and I want data, or I want a z-score, percentage I go backwards, what do? Inverse norm. So I would do inverse norm of 0.75, and my guess is one of those answers is that. It's A. So that's 0.67. So that's what they're trying to get you to put if it were normal, but it's not. Questions on that? Or like the made up version of it? Yeah.
If it was normal, I did like the z-score formula, and I used like the same data point they used on the top for 85 rounds, and I got like a similar answer from. I knew it was like
For number one, you used those? Wait.
for number one, that first part, I used the data point as 85 and plugged in as the z-score first.
Yeah, those are two separate questions.
Okay.
So you couldn't do that. Like do the z-score formula, you would need x bar and mu and standard. You need all that stuff. And you just don't have it. Like that's a separate deal. Other questions? Robo? The 20 is how many dots are down below that 85 line. The 28 is how many dots there are altogether. Alright, for 9. So we got a mean of 80, a standard deviation of 2.5. So this right here represents the mean minus 2 standard deviations, which would be 75. And this represents the mean plus 1 standard deviation, which would be 82.5. And so basically I'm just looking for those numbers. So it's A. Fair enough? deviation talks about how spread out the data is, right? Like the shape of it. So if I add 4 to every number, all that's going to happen is that exact same shape will just move over 4 slots. Pick off that normal curve, move it over every data point over 4 slots and set it back down. So does the mean get bigger? Yeah, every point got 4 bigger, so the mean is also going to get 4 bigger. You know, if I have like 3, 4, 5, 6, what's the, here, let's do 7. What's the average of those? 5. Now let's add 4 to every data point. What's the average of those? 9. So when I added 4 to every data point, I added 4 to the mean, right? But the amount, like how spread out it is, did not change. These are the exact same, like spread away from the middle as these, aren't they? This shape didn't change. So what I'm getting at is the mean gets 4 bigger, and the standard deviation stays the exact same as it was. Because standard deviation is like shape. And the shape didn't change, you just picked it up, moved it over. It's like you click it and drag it and let it go. So if I start multiplying points, like say I multiplied all these by 2 even, well now, like the distance from the middle to the outside used to be 2, just as an example. And now the distance from the middle to the outside is 4, so now I made it more spread out. So when you multiply, it spreads things out more. Is that page right? Did we do 10 in class, right? Alright. Z-score of +2 on the exam means you were 2 standard deviations above the mean, which is kind of a definition, so it's E. We did this one in class 2, right? Alright, I got a mean of 139. I got a standard deviation of 26. Lowest 10%. I'm looking for the actual blood pressure. So I'm looking for X bar, right? I'm looking for the actual data point. So I know the Z-score formula. And I have everything except a Z-score, but they give me enough information to find a Z-score. If it's in the lowest 10%, how can I find the Z-score? Inverse norm of 0.1. And that's just going to give me a Z-score. So negative 1.28. And then I know everything I need to know to throw into this formula and do some math. So ideally I'd go like percentile, I would just do this and go from the percentile back to the data point and type in the mean of standard deviation. Oh. Yeah, I could do that. I made this harder than it has to be. I know everything I need to know. So I could just go inverse norm, 0.1, tell the calculator the mean, tell the calculator standard deviation. I did it in 2 steps, but I could have done it in 1. So it's like 106. Yeah.
How do you know under 2.1 or 0.9? Like that confuses me.
You're always putting in the percent that is lower than you. So if it says lowest 10%, you're putting in 10. If it's at highest 10%, you would put in 90 or 0.9. You're always doing the part at the bottom. 23 is very similar to one of the ones we did yesterday. So just in the interest of time, I guess I should ask. I should get the answer first. Should I go through this, or is this one okay? This one's okay. What was the answer? D? Okay. I'll take your word for it. 27 is another one of these. This is about, there's a couple ways you can do it. 8,000 out of 20,000 is 40%. So this is basically asking for the middle 40%. So you can do that a couple ways. You could work backwards from these answers. You could type in like normal CDF for each one of these answers and see which one gives you 0.4. Or if I want the middle 40%, this would be inverse norm of 0.3, because there's 30% down there. And then the mean is 12, and the standard deviation is 2.5. This would be inverse norm of what? 0.7, and then 12 and 2.5. Not on a multiple choice, but I should write it every time. Just to... So it's D. You type those in. Is that right? And just to like verify, if you wanted to, go ahead and type in normal CDF, like just to check your answer. And what should this give you? This should give you 0.4 because we're looking for 40%. So you can try to get at it two ways, and that always makes me feel better if I can do something two ways and I get the same answer both ways. I'm pretty sure I'm right. 40, which one is the largest standard deviation? So you want the one that has more points further away from the middle and less points in the middle. And if you look at what they did, distribution A, like these 2 points came from there and there. So if you took these 2 points that are really close to the middle and spread them out further away from the middle, that's going to create a bigger standard deviation. So A has the largest standard deviation because it's just more spread out. Like this is a moodier person than this is. Yeah.
I was gonna put A, but I didn't think the numbers for distribution B were like the same deviation as like the top, because they didn't write it again on top. Because I always wrote like when they show two, they show the numbers on the bottom for both graphs.
Yeah. Yeah. So like this 20 applies all the way up, is that what you're saying? Yeah. Is that okay then? Alright. What's the probability x will be less than or equal to negative 0.6? Well, negative 0.6 is like right there. And remember, probability and percent and area are all the same. So I want the area of this little part of the box. So what's the base of that rectangle? 0.4. And what's the height of that rectangle? It's 0.5. If I multiply those two together, I get 0.2. So it's 20%. You can have like a negative probability, so it's not going to be. It's not going to be B. What's that? Great. Awesome. All right, 28. So I've got a mean. Mean rate is 0.12. I got an X bar of 0.15, and that is in the 80th percentile. And I'm looking for the standard deviation. So I'm kind of looking at this and going, what do I know? What do I not know? What do I need to know? I need to know this. I need to know the standard deviation. I know these two, and I can find that. And then I can work with that. How can I find the z-score? Inverse norm of, so if it's the 80th percentile, I'm doing inverse norm of 0.8. So that's 0.84, and then I'm going to use that formula and go, okay, well 0.84 is equal to x bar minus mu over standard deviation. Remember that little trick where you can swap these? So that's 0.03 divided by 0.84. So it's like 3.57%. So C. Questions on what I did there? Is this helping? Alright, problem? So again, I'm going to write down what I know. The mean is 65. Standard deviation deviation is 2. I want X bar, and I know the 99th percentile. Well, I have all the information I need to use that. So I want to go. I have the percentile. I want to go back to a data point. I have the percentage. I have the mean. I have the standard deviation. So I can just go straight to inverse norm. 99th percentile would be 0.99. Tell the calculator the mean. Tell the calculator the standard deviation. And I get 69.65. So that's D. Good there? Questions? Stop. Go faster, go slower. Okay. Which of the following is the best estimate of the standard deviation shown above? So think about, like, you almost have to just trial and error this. Remember that what percent of the data is supposed to be within 1 standard deviation of the mean? 68. 2 standard deviations? 95. And then 3 is basically 100%, right? 99%. So if you made your standard deviation 5, that would mean 68% of your data is between there and there, which I can't really necessarily argue. But then that would mean 95% of the data is between there and there, and 100% of the data is between there and there. Does that seem like it fits? It does. Let me try a bigger one just as an example. The answer is 10, but just like to show you why 30 wouldn't work, that would mean 68% of your data is between 80 and 20. And that's not 68% of the data, right? It's like all of it. So that's too big of a standard deviation. But if I do 10, does it make sense that 68% of it's there, 95% of it there, and basically 100 of it there? I mean, that just seems to match, right? So there's no like math way to do it. You just kind of eyeball and trial and error and see which one fits the best. And if I gave you like 9, 10, and 11 as choices, you'd have no way. Like they're gonna have to spread them out far enough that it's obvious which one's which. All right. 25, I think, is a relatively easy one. You're gonna find the z-score for both. Yeah, and then just compare them. So the chemistry z-score would be 81 minus 75 over 12. That's 0.5. The calculus z-score would be 84 minus 80 over 8. And that's 0.5, so the student did equally well in each course. I don't remember putting that as an answer. Is that what you guys got? Yeah. Is that what I have on this on school? Oh, okay. I thought I put something different. Is that right? 3 more here in the back. So 32. Okay. Let's see what we got here. I'm not even sure how I'm attacking this yet. I'm just drawing stuff. So I got 10% of the loaves weighed less than 15.34 ounces. So 15.34. That's going to be 10%. So I can find a z-score right there by going inverse norm of 0.1. I'm not even positive I need the z-score yet, but I have a feeling I will. So this would be, if I needed, z equals negative 1.28. Up here, 20% weigh more than 16.31. So this is 20%. And I can do inverse norm there too. I'm going to do an inverse norm of what if I want this spot? Sarah? 0.8. Because I want to do the part that's below. So that's 0.84. What are the mean standard deviation? Is this seriously like systems of equations? Alright, here's what I'm going to show you, and then let's just see what we get. So with this information here, I can go negative 1.28 equals 15.34 minus x bar over standard deviation. Agree? That's just z equals, no, sorry, minus mu. Yeah. With this information here, I can say 0.84 equals 16.31 minus mu over standard deviation. Agree? So what this is suggesting to me is that I'm supposed to use systems of equations. Everybody do this differently. There's got to be an easier way to do this. So like, I could go through and solve these equations, but I can't imagine that's the easiest way to do that. That's ridiculous. I wouldn't give you one like that. What did I do on the answer key on school sheet? Did I do this? This would be one, like if I gave you this, it would probably be an extra comment. Yeah, I'm not going to worry about that. So don't worry about that for like the main part of the time. If you want me to go through it with you later, I'm happy to. That's a little more than, that's extra. Resistance outliers. So that means like if I give you 4, 5, 6, 7, 8, and then I change it to 4, 5, 6, 7, 9, 9, 9. Resistant means that that doesn't change. So like with the median change in this case, going from there to there with the median change. No, so the median is then resistant. With the mean change, yeah, so the median is not resistant. Like it can't resist changing based on that outlier. So which of the following are resistant? Well, mean is not resistant because a bigger number would change the mean. Median is resistant, but is standard deviation resistant? No, like didn't I just jack up the standard deviation a ton by making that a bigger number? Median is fine, but what about range? Didn't I just change the range too?
Yeah.
Median's fine. IQR, did the IQR change? So the IQR is like based on these numbers in here. Did that change? Well, with this small of a data set, it actually would. But let's say I had like 1, 2, 3, 4, 5, 6, 7. That'd be your median. That'd be Q1. That'd be Q3. Change the 7 to a 10 million. Do Q1 and Q3 change? They do not. So median and IQR are what you're looking for there. And then 26 is very similar, like that one or the bear one. You're like finding the z-score and matching them up. Should I go through this? Yeah. So, course A has a mean of 76, a standard deviation of 8. Course B has a mean of 80, standard deviation of 6. If this guy shoots an 80 here, then find the comparable score on course B. So an 80, let's just eyeball it. How far above the average is 80? 4. And the standard deviation is 8. So isn't he half of the standard deviation above average? So I go, okay, Z is 0.5. Z is 0.5. So if this person is half of the standard deviation above average, what's that going to be? 83, because you would take half of 6 is 3 and add it to 80, so 83. And you can do the formulas and stuff too, but some of those are a little easier to just do with like basic numbers in your head. How's that? Does that help? Alright, there's another, I'm giving you last year's test. You don't want more practice?
No, I just
What? What?
To grow your hair, how long does that take?
Oh.
You get it?
Yes, I got it. So hilarious.
responses. The free responses from this topic on the AP test will combine with other stuff that we haven't learned yet, so I can't really give you free responses on this. So it's all going to be multiple choice or fill in the blank or short answer. Yeah, so no free responses. There'll be 20 questions. Will be due at the end of the hour. That's actually more time per question on the AP test gives you. The answers are on Schoology right now, yeah, so you can check them as you're going. You have the rest of the time to work, ask questions, whatever. Then as soon as you come in tomorrow, get that testing road. Get after it. Questions? Your con is due tonight. Also, if you want to use this stuff for con, I have no problem with that either. Con is just studying. I mean, it's the same stuff, you know. Is the AP wording even better than con wording?